Hello students, so we will discussing about the how to run a practical in Quantum Expresso. So first need to the download Quantum Expresso. For this is Quantum Expresso 7.1, and if you successfully install, then you see the bin, and this bin file indicate that your Quantum Expresso file, it's basically library, was successfully installed. So now we need to any potential, we need to sudo potential. So let's see how to download sudo potential. So first go here. Now I go to a Quantum Expresso website. This is the www.quantumexpresso.org, the official website, and going to the user section and going to the sudo potential. Click the in sudo potential. You see it here. You get the sudo potential for the standard storage state potential, sudo potential. So click here, and after the clicking you get it download the sudo potential. Or sometime you need to the another potential, like if we calculate the any another quantity, so we require the another potential. So go here and are available here sudo potential. So any type of the whatever you need to the like a calcium, sodium or zinc, whatever you need, you get it your sudo potential. Like I will try to the find out for the Ag. So it is basically silver. So if we find out the Ag, then we get the Ag sudo potential, right? So this is the all basic thing. This is Ag, and we get the all are the sudo potential, right? That so download any sudo potential must the UTF try to get it. Now we go to in the inner section. So this is the all the thing basic we have, whatever we require. Suppose I require the Ag, so search in Ag. So search Ag, so we get like something Ag, like this is the file. So copy this file in the folder. I already this is the file I already copy paste here. This is the script for the write a script in the ag.scm.in. So let's understand this script. So first this is all are the parameter, or I can say the channel. So first have control, so we need to this something control. So this is the calculation for the SCF. So this is the full form of SCF, the self consisting function, right? It will be considered the function. So I already said that down put the your file in the SCF. Now I will try to the run my Quantum Expresso program for the silver. So this is the from the reset from the now we need to scratch. So why we need scratch? So for this scratch any type of the value that we have already in the our Quantum Expresso program or in their file, so it will be automatically delete, right? The prefix, this is the prefix which we use in the entire the section. So write a Ag, I will you write the anything whatever you need it. And now for the sudo directory, this is the sudo directory which we have the in the our same file. So I will write this in the comma and plus here the dot, so I indicate that. And then after that out directory we required to the out directory for the basically for the temp file, right? This is the temp directory. So temp directory was the in the sense indicate that the folder was in the save in the temp directory, same folder, right? So this is first slash was indicated in this folder. And the another channel is the system. So how to system use, though is this is the brevis latest the full the cell dm are there in the 10.2. So now the question is the how to find out the cell dm. So using the we have the some value in the angstrom, then the divide by 0.04526, so you get the answer, or 0.516, like that. And number of atom here only one, and number of type 1. So now here the question is that the how to we know about the number of atom. So it is the nothing but going to in the this is terminal, and go to this channel materialproject.org. This is the website materialproject.org. So go it there, and you get the material.org project. And now we'll open it. Right, if you one time the here get it, this is the home page. So I again try to see home page. And this is the AG basically a silver, right? So now go to here and download the CIF file, right? So this is the basic thing. Download the CIF file. You see it here. Your CIF file for the easy was already downloaded, right? So this file was open, and then whenever you download your CIF file is the here, and then you get it when you get the CIF file. So I will download it already in this CIF file here. So you get it here, and then after that you open your the Vistas application and go to here for the find out. This is the for the AG, right? ag.cif.vista. So this is if you need to the collect this, so go to in the file section and then go to open and the extract whatever you need it your as per the requirement. So as per the you get it and open this thing, and you get it the same file was open. So ag.cif in Vista open. So now how do we get the R parameter? So go to in the file section and go to in the export data, then download is the VASP file, right? It will be like that. And then download the in the Q section. Then after the you go the save, then go to in the fractional coordinate, and here consider the primitive cell, convert into primitive cell, then okay, then your file will be already installed. So let's see it will be installed or not. We get it the output data in the CIF file like that. This is the CIF file, and after the CIF file we get the 1Q Vespa. So this is the all the about the this is the Vespa, and we get the 4 element. This is the like this is for the magnesium and zinc. We similarly get for the here for the AG we get this parameter for the only one atom. So you get it using the Vista. So this is the all the thing that we needed here. So first of all, in the metal, always if you do not do this process, then you always get the in the model 0.00 form. So not required to you go to in the website and download the all the things. Just write the 0.00 for the metal, and you get your answer in easy way. Then E cutoff wave function we vary it as per the condition. So if I require here the 40.0, so I do it 40.0, and now this is the all these things that is the most important in the for the metallic substance. So occupation equal to smearing. So this all the thing documentation you get it in the quantum expresso website, and this is the all about this thing as you get it your all this thing, right? So this is the occupation that I write here in my program. So you see this is the occupation and equal to smearing, and for the smearing, this is the smearing. If I click the smearing, then you get it. This is the MV point. So for the metallic surface, we consider always the MV, right? So this is the all about this thing. And then another thing is that the D goes. So please be careful about the in the writing any type of the not syntax error or syntax mistakes. So you get it your answer in easy way. So electrons we consider the here the always having the 10 to the power minus 8 D minus 8 it indicate the 10 to the power minus 8 value, and mix in beta always you consider 0%, not required to change it. And atomic space, this is the for the AG always write a capital and small g. For the atomic mass 47, and this is the potential file whatever we consider it. You see the I download and just copy this name here, and this is atomic unit, and K point was considered the automatically 8111 for the initial stage. And now the after this all the thing the put the control S, and then you see this all the thing done. So after the all the exercise for the ag.cf.in, then open the in the terminal and open the gedit, and for the gedit you write the first bin and bash. So this indicate that your program was started. Echo is the one type of the comment, right? This is the basic comment in echo. Name is indicate that be careful here the write the noun. Whatever you write now, your file was saved in the same value. And then the after the for cell dm value you get it this value. So how to write this value, this is the important this thing. So first whatever you have the in the cell dm value, like my value is the going to the like 7.5 something, so I go to 7 to 11 or like that, right? And then n control, then all these things same as we write is the earlier. So just copy and paste. The one thing more thing is indicate that cell dm here I will write the value, but here you write just as this is the symbol for the dollar and cell dm. So all these type of run was the done, right? Otherwise you need to do more exercise. Then another thing, all these thing is e of s is the indicate that end of function, right? npwx.name, the name is the at the cell dm. So whatever these write in the cell dm, the folder we get it and get it the in the cell dm output. So input and output both the directory, both the file are saved here. Now the awk. So now why we need the awk? For the total energy to the extract to the program, we need to the awk. So write down this program. So let understand the how it will be explained. So this all the thing is the e5 is indicate that in the total energy going into 5 row and this one column, and pwsf is the predefined. Printf sss is indicate that at this n. Then this is the cell dm, whatever we get the data, and for the up to 3 digit. And so this is the all the thing you need it. And then if you write any comment, so in the write in echo and all this thing, and then do control s. So this is the basic thing. So now I minimize and open the in the terminal, then open the terminal, then write the ./vol.sh and go to enter, and you see it my calculation was started. And similar way you get it file was generated here. And so you get it input and output both file generated. It will be helpful to us. It takes some time because I increase the value of the loop, because in the quantum expresso just you think about I get the only one atom. If I take the 4 to 5 atoms, it will be too much larger and take too much time, right? So this is for the 10.5. So job was done, right? This is the for the symbol for the echo. So job was done. Then see in the total energy what we get. So you get it. This is the data that I get it. So now another thing that we required, that go into terminal, then the ev.x, then the lattice parameter. So what here we consider lattice parameter is the atomic unit. So here are the lattice parameter for the atomic mass unit, and then the Bravais letter is FCC, because you know that the silver is FCC. Then the RDF4 is the known as the Murgan. So Murgan here we consider for the FCC. So write 4 and then enter this value and input file whatever we need to input back. So now here we get the input in the total energy. So write a total underscore ene dot dat and then put enter, and the output file. So I need output in the volume. So volume, write a volume and output. So OUT, then put it enter, then you see it, the volume dot output was generated. So let's see, this is the value. So you see the pressure was varying here to here. Then let's do the another exercise. This is the for the volume output. Then go again in the terminal section, right? So going in the enumerium section, then the open the GNU plot. If you not have GNU plot, then install it using the sudo apt install GNU plot. In the GNU plot you get is this all these things, and then first you write here this thing. So first write the plot, then in the inverted comma, write total underscore energy dot dat, right? So this is the for the JNU plot, get the data from the energy. So space u gen 1 gen 2, it indicate that the first column and second column we required to consider it, right? Then w, then lp. So get enter. So you see this, we successfully draw their graph. So sometimes we require the something modification in the graph. So click here again and write something additional. So first write the unset key. Unset key. And enter this thing. After the writing unset key, we write the set. We require the write down the x and y axis. So set x label, label, set x label, and then space in the inverted comma. Lattice constant. Lattice constant. Then write the set in a y label. So our y label was need to space. So energy. So write energy. Energy in the form of electron volt. So write here just a EV, right? And then enter. Oh, it will be invalid command because we need to here the write a set, right? So let's valid or not again. Yes, valid. Then repeat process. So write REP, just REP, then you get it. We get it. This is the energy and lattice graph. So how do you conclude that for the minimum energy we get the this is for the this lattice constant. So for the lattice constant, and this is the energy for the y-axis energy, and this is the lattice constant. So this is all about this thing. How do we save? So going in the here and the write down this AG. Now I need to the PDF file, then save this all this thing. Then this is the all the thing, right? AG, and this are the file basically that we get it. Oh, finally we get our the graph. Let's zoom out. Right, energy versus lattice constant. So this is the all about the quantum express of time. I hope you understand this thing. Thank you.